Hey guys, welcome to this video, and I'm going to go over how we can solve this amazing trig identity of sine theta, tan theta, all over 1 minus cosine theta minus 1 is equal to secant theta. So now to solve this, to verify, to prove this trig identity that's a little bit complex, not too complex, a little bit, we're going to use three basic trig identities that you may have already come across. So these are tan theta is equal to sine theta over cosine theta, secant theta is equal to 1 over cosine theta, meaning secant theta and cosine theta are the inverse of each other, and the more basic one of sine squared theta plus cosine squared theta is equal to 1. You might recall this from the unit circle. Now we're going to use these three trig identities to solve this one. So let's begin. So the first thing we understand is we have to, we're going to begin by combining these two terms on the left side. So we're going to say sine theta, and also we're going to use something right away. Remember this part, we're going to change this to this. We're going to say sine tan theta is going to become sine theta over cosine theta. And this is going to be 1 minus cosine theta. And minus, we're going to combine the denominators here. So negative 1 becomes 1 minus cosine theta all over 1 minus cosine theta. Now, the next part, let's combine the denominators, and we got the numerators together. Okay, so let's move down a little bit. Now we have sine theta. Now we're gonna multiply the sine theta together, so we're gonna have sine squared theta all over cosine theta, and then we have the common denominator of 1 minus cosine theta, then minus the numerator combines, and we have minus 1 minus cosine theta, and then now we have a so now let's multiply. Let's bring it all out together. So we're gonna take this out of the brackets. So we're going to have cosine theta is equal to minus 1 plus cosine theta all over 1 minus cosine theta. Doesn't that look pretty? So let's get back to the next step. Sine theta, we have a problem here. We have a big problem here. We don't want this denominator here because we already have a numerator that has a denominator inside the numerator. We don't want that. Complexity, not good for verifying the trigonometry equation. So let's go over here and let's get rid of this cosine theta. So we're going to say multiply the top by cosine theta, bottom by cosine theta, and we're going to multiply it here, okay? And then we're going to say sine squared theta, because the cosine cancels out. We have minus cosine theta, because cosine theta minus times multiply, negative 1 equals minus cosine theta. And the cosine theta multiplied by cosine theta becomes plus cosine squared theta. Isn't that beautiful? Isn't that magical? Then at the bottom, we're not going to multiply out because we're going to cancel it the next time, as you will see. So we have cosine theta multiplied by 1 minus cosine theta. And the next step, this is a critical step here. Remember this, go back here. As you can see, we have sine squared theta plus cosine squared theta is equal to 1. This one right here. So if we take a look down here, we have sine squared plus cosine squared, right? So that becomes 1. So sine squared plus cosine squared equals to positive 1. So we have positive 1 here. So we have the top, this equals, the numerator is minus 1 minus cosine theta. At the bottom here, we just copy and paste it here. 1 minus cosine theta. And what do you know? We can cancel this, right? That becomes 1 over cosine theta. And last but not least, this is the inverse of secant theta. Remember, if we go back up here one more time, we have secant theta is equal to the inverse of cosine theta, which is 1 over cosine theta. So we have cosine theta here, 1 over cosine theta, and that becomes secant theta. And we have our proof. Now go back to our original equation. We were looking for secant theta. This trig identity has been verified. I hope you guys enjoyed this video, and I hope you pass your math exams.